chapter 1, chapter 2 dengan chapter 3 until integration by using substitution method je. Okay, so hari ni saya nak continue with chapter 3. So saya nak habiskan chapter 3. Last week for partial fraction, kita dah cover for case 1 and case 2. So today saya nak continue with case 3, case 4 and case 5. Okay. Okay, so for case 3. Okay, so saya recall sikit for case 1 and case 2. Okay, so from last class for case 1. Okay, case 1, we have a linear factors. Denominator is in terms of linear factors. For example, kita ada 6 minus x over with x minus 2 and x plus 2. Okay. Okay, so for a general form of the partial fraction is a over x minus 2 plus with b over x plus 2. Okay, so ini when both of the factors or all the factors are in terms of linear. Okay, so ini is the general form of the partial fraction. Next we have case 2. Case 2 is when the denominator is in terms of repeated linear factors. For example, we have 6 minus x over with x minus 2 to the power of 2. Okay, so also equal to a over x minus 2 plus with b over x minus 2 to the power of 2. Okay, so yang ni partial fraction for case 2. Okay. Or we have 6 minus x over with x minus 2 to the power of 3. Okay, so you punya form dia for partial fraction is a over x minus 2 plus b over x minus 2 to the power of 2 and plus c over x minus 2 to the power of 3. Okay, so ni saya bagi you dua example lah for case 2. Case 2 for linear and with repeated factor. Okay, so ini pun sama linear tapi dia repeat. So ini repeat 2 times and then this one repeat 3 times. Okay, so ini for case 1 and case 2. Ini yang last class lah. So today we have case 3. So case 3 is for partial fractions with irreducible quadratic factors. Okay, so ni you kena ingat form dia. Form partial fraction for case 1 and this one form of partial fraction for case 2. Okay. Next for case 3, denominator with irreducible quadratic factors. So irreducible quadratic factors is a quadratic polynomial which cannot be expressed as a product of two linear factors with real coefficient. Okay, so irreducible quadratic factors is a quadratic polynomial. So kalau you nak check dia, you can use b square minus 4ac. So for irreducible, b square minus 4ac is less than 0. So kalau you tengok, ingat lagi yang belajar last semester, if b square minus 4ac less than 0, the roots is in terms of complex number. So that's why when the quadratic equation is in terms of b square minus 4ac less than 0, then we call as irreducible quadratic factors. So you cannot be factorized lah. Okay, so cannot be factorized into real coefficient. Okay, so for each irreducible quadratic factors, so ni example ax square plus bx plus c, the corresponding partial fraction is of the form ax plus b. Okay, so ni you kena ingat lah. For example, irreducible quadratic factors ni kita ada x square plus 1. Contoh you ada denominator ni is x square plus 1. So x square plus 1, if I check using b square minus 4ac, okay, b dia is 0, minus with 4, a dia is 1, c dia is 1. So you akan dapat the less than 0. So less than 0, consider as irreducible quadratic factors. So for example, kalau you punya equation tu is 6 minus x over x square plus 1, so you punya partial fraction is ax plus b over x square plus 1. So tak perlu factorkan yang x square plus 1 ni. So you copy je balik, tapi yang di numerator dia you must add ax plus b. Okay, so sama juga kalau you ada x square plus 4. So x square plus 4 pun diskriminan dia, kalau b square minus 4ac you have 0, minus 4, a dia 1, c dia is 4. So also you have less than 0. So less than 0 also irreducible quadratic factors. Contoh kalau you ada 6 minus x over with you ada x square plus 4. So sama juga you punya partial fraction is in terms of ax plus b over with x square plus 4. Okay, so tak perlu factorkan yang x square plus 4. Okay, so ini example of the irreducible quadratic factors. Okay, so you can refer to example, contoh yang example 28 ni. Okay, so factor dia for the denominator we have x dengan x square plus 4. So x square plus 4 is a irreducible quadratic factor. Yang x ni is case 1. So ini is a linear case 1 and then this one is case 3. So they combine case 1 and case 3. So you punya partial fraction is in the form of a over x. So a over x ni you gonna refer balik case 1 and this one is for case 3. Okay, so kalau irreducible quadratic factor, so you kena ingat you punya numerator must be in terms of linear. Okay, so linear and then this one is the quadratic. Okay, so ini you punya general form of the partial fraction. Okay, so you dah determine partial fraction, next you boleh solve. Solve dia sama macam biasa, macam case 1 and case 2. Okay, so you kena samakan denominator, lepas tu you cancel denominator and then you need to solve for A, B and C. So this example, kita solve using comparing coefficient. Okay, so A dia is 3, C 0, B negative 2. Okay, and substitute values, lepas tu kita boleh integrate. Okay. Yang ini for principle. Okay, next example 29. Okay, so saya tunjuk you example 29. Okay. Okay, so you can refer your notes on example 29. Okay, so example 29. Okay, we need to integrate x negative x squared plus 2x plus 2 over with x cubed minus 1 respect to x. Okay, first you need to factorize the denominator. Sama macam case 1 and case 2. First step dia mesti you factorkan denominator. Okay, so for cubic function, so kalau you nak factor you boleh check using calculator. So nanti dia akan bagi you dia punya root of x. So kalau you check guna calculator, root of x dia akan bagi you one value je. Dia akan bagi you x equal to 1. Okay, sebab yang values yang lain tu is in terms of complex number. Okay, so tu dia bagi satu value. So you have x equal to 1. So from x equal to 1, you boleh derive the factor is x minus 1. Okay, so you boleh recall balik chapter polynomial yang last semester. Okay, so kalau you ada cubic function and you have one of the factors, so you boleh solve using long division or synthetic division. Okay, so for example, saya solve using long division method. So you boleh divide x cube, so plus 0x square plus 0x minus 1. So saya divide with x minus 1. Okay, so saya boleh divide dengan x minus 1. Such dia is equal to x square. Okay, so x square plus with x plus with 1. Okay, so nanti kalau you solve, you akan dapat remainder equal to 0. Ni saya tak buat complete lah. So you boleh refer balik yang last semester punya topik for polynomial long division. Okay, so sekarang you dah factor. So I have negative x square. Okay, so over with x cube minus 1. So after you factorize, the denominator becomes okay, over with x minus 1. So you ambil ini x minus 1 dengan answers dia. So you have x square plus x plus 1. Okay, so you have linear factor and also quadratic factor. Okay, so sama juga macam case 1 sebelum ni, case 1, case 2. So bila you ada quadratic factor, you kena check lah. So dia boleh factor atau tak boleh factor dah. Okay, so saya nak check, you boleh check using calculator. So kalau masuk calculator pun sama, dia akan bagi you complex number untuk solution for this quadratic equation. Or you can check using b square minus 4ac. Okay, so for example, saya check using b square minus 4ac. So b dia is 1, minus with 4, a dia is 1 and c also 1. So you akan dapat the less than 0. So kalau less than 0, maknanya you tak perlu factorize lah. Okay, so maknanya you akan dapat dah bentuk simplest form. So ni dah bentuk simplest form lah. Okay, so saya nak determine the partial fraction. Okay, so you have denominator x minus 2 and x square plus x plus 1. Okay, so for the denominator, x minus 1 is for linear. So linear, so means that we have case 1. Okay. For x square plus x plus 1, so you dah check the less than 0. So kita consider as irreducible quadratic factor. So kita so in case 3 lah. Okay. So they involve case 1 and case 3. So partial fraction for case 1 is a over x minus 1. For case 3, mesti linear bx plus c over with x square plus x plus 1. Okay, so ini you punya partial fraction. Next, step dia macam biasa, you kena samakan denominator. So x minus 1, you nak tukar into this denominator, so you need to multiply with x square plus x plus 1. Okay, so atas pun sama, multiply with x square plus x plus 1. Okay, and for term bx plus c ni, denominator dia you need to multiply with x minus 1. So atas pun sama, you multiply with x minus 1. Okay, so you have over with x minus 1, x square plus x plus 1. Okay, equal to a times with x square plus x plus 1. Okay, plus with bx plus c times with x minus 1, and denominator is equal to x minus 1 times x square plus x plus 1. Okay, so denominator dah sama, you boleh cancel. Cancel the denominator, then you need to solve for the numerator and calculate values a, b and c. Okay. Okay, so saya copy balik yang tadi. You have for the numerator negative x square. Okay, negative x square plus 2x plus 2 equal to a times with, okay, so ni saya copy balik yang ni yang last ni. Okay, saya copy the numerator. So plus with bx plus c times x minus 1. Okay, so you boleh solve using comparing coefficient or you nak solve using substitute values, substitute suitable values of x. Okay, so for example, I choose method substitute values. Okay, so saya assume x. So saya assume x tu is equal to 1. So x equal to 1 based on this one. Okay, so x minus 1 equal to 0. So x tu saya ambil equal to 1. Okay, so saya substitute semua dengan 1. plus 2. Okay, so equal to A, 1 square plus 1 plus 1. So plus with Bx plus C, 1 minus 1. So automatic this term becomes 0. So 1 minus 1 is 0. So dah 0 kat sini, you boleh terus calculate value for A. So A is equal to 1. Okay, so you dapat A equal to 1. Next, saya nak calculate value for C. Okay, so lagi satu you boleh assume let X is equal to, so yang ni saya tak pilih lah. Sebab kat sini kalau you check values of X tu dia akan dapat complex number. Okay, so saya ambil X tu, saya ambil base pada sini. Okay, so bila saya X equal to 0, nanti B akan jadi 0. So you boleh calculate value for C. Okay, so when X equal to 0, so substitute semua dengan 0. Okay, plus with 2 equal to A, you substitute dengan 1. Okay, so 0 square plus 0 plus 1. So plus with B times 0 and plus with C. So 0 minus 1. Okay, so this one, term ni becomes 0. Okay, so you boleh calculate for C. So C is equal to negative 1. Okay, so when C equal to negative 1, next we have the last constant. Okay, we need to calculate value for B. Okay, so total constant, we have 3, A, B and C. So bila you dah calculate the two values, the first two values of constant tu, so yang last constant you can calculate using substitution of any values of X. For example, saya choose let X is equal to 2. Okay, so when X is equal to 2, you boleh substitute all X with 2 plus with 2, so equal to A, substitute with 1. So you have 2 square plus 2 plus 1, so plus with B. Okay, so kita nak calculate B. So B times 2 plus with C, C is negative 1. Okay, and 2 minus 1. So kalau kita ada constant B je kat sini. So you boleh terus calculate B. So B is equal to negative 2. Okay, so kita dah complete lah. A1, C negative 1 and B equal to negative 2. Okay, so solution ni you boleh screenshot. Okay, so you have A, B and C. Next, you boleh substitute into partial fraction ini. Okay, general form of the partial fraction. Okay, so saya copy balik. So tadi partial fraction we have, so over with times with x square plus x plus 1. Okay, so partial tadi kita ada A over x minus 1 for case 1 and for case 3. So we have bx plus c. So we have bx plus c over with x square plus x plus 1. Okay, so kita dah calculate A, B and C, substitute je, equal to, substitute A with 1, so 1 over x minus 1, and B with negative 2, so plus with B is negative 2x, and C is negative 1, so minus 1, over with x square plus x plus 1. Okay, so you boleh simplify lagi, 1 over x minus 1, so kat sini saya factorkan negatif, so you have 2x plus 1, over with x square plus x plus 1. Okay, so aim dia kita nak integrate. Kita nak integrate this side. Okay, so saya nak integrate yang ni. Okay, so sama jugalah kat sini pun saya nak integrate. Okay, so answers dia equal to 1 over x minus 1 is equal to ln x minus 1. Okay, so untuk yang last fraction ni, okay, you need to solve using substitution method with u equal to x square plus x plus 1. Okay, so du over dx is equal to 2x plus 1. Okay, so saya integrate minus. So saya solve using substitution over dengan u. Lepas tu times dengan dx. So dx is du over 2x plus 1. Okay, so you boleh cancel 2x plus 1. Okay, so ln x minus 1 and you need to integrate 1 over u. Integrate 1 over u also ln u plus with c. Okay, x minus 1. So substitute u with x square plus x plus 1. Okay, plus with c. Okay, so ini solution for example 29. Okay, so ni untuk case 3. Ada soalan tak? For case 3. So ni boleh screenshot ni. Tak ada? Okay, so
Tak ada, madam.
tak ada. Okay, so saya nak continue with partial fraction with repeated quadratic factors. Okay, ni case 4 lah. Okay, so case 4 dia ada quadratic factors tapi dia repeat. Okay, so you can refer to this example. Okay, so saya refer to the denominator. Okay, you have x. So x ni is a linear. So dia case 1. And 2 plus x square. 2 plus x square is case 3, irreducible quadratic factor. So kalau you check 2 plus x square ni is b square minus 4ac, dia is less than 0. Okay, so kita categorise dia as case 3 lah, irreducible quadratic factors. Next, for the third factor, you have x square plus 3x plus 1. So yang ni also case 3. Sebab kalau you check using b square minus 4ac tu, you have b dia is 3 square, so minus 4, a dia is 1 and c dia is 3. So you can dapat dia less than 0. Okay, so kita consider as irreducible quadratic factor. So dia irreducible quadratic factor tapi dia juga ada repeat kat sini. So kat sini kita consider as case 2. Case 2 yang repeat. Okay, so you punya partial fraction, first for case 1 kita ada a over x. Lepas tu case 3, 2 plus x square. 2 plus x square and the partial fraction must be in terms of linear lah. So we have bx plus c. For the third factor, we have x square plus 3x plus 3. Also irreducible. So irreducible, so you punya numerator linear, dx plus e. Tapi dia juga repeat 2 times. Okay, lepas tu kita ada satu kat sini. Lepas tu lagi satu kita ada sekali lagi lah. So ini power 2. Okay, so atas dia still linear, fx plus g. Okay, so kalau example ni makna you need to calculate until a constant g. Okay, tapi ni untuk example je lah. Okay, so ini untuk yang case 4. So case 4 ni addition dia yang ini je. Yang dia kuadratik, dia irreducible, and dia kuadratik tapi dia repeat. Okay, dan juga dia irreducible quadratic factor lah. Okay, so ini untuk case 4. Next, last we have case 5. Okay, so case 5 is for improper rational expression. So ini yang last. Okay, so before kita dah ada case 1 until case 4. Okay, so all these 4 cases ni involve proper rational expression. So example of the proper, you boleh refer balik definition of the proper. The polynomial ataupun the power, the degree for the numerator must be less than degree of the denominator. For example, you need to divide x minus 1 over x square minus 2. Okay, so yang ini kita consider as proper lah sebab degree for numerator is 1 but the degree for the denominator is 2. So atas ni lagi kecil degree dia compare to yang denominator. Tapi kalau improper, okay, you punya degree dia equal, contoh you ada x minus 1 over x minus 2. Ini pun consider as improper. So degree dia equal, or degree for the denominator is less than degree for the numerator. Contoh kita ada x minus 1, sini x cube minus 1 over dengan x plus 1. So ini kita consider as improper lah. So degree atas ni lagi besar compare to the denominator. Okay. So ni example of the improper. So untuk case 5 ni kita nak solve yang bentuk macam ni lah, bentuk improper. So for teknik dia, kita ada 2 step. First, you need to express as a sum of polynomial and proper fraction by using long division method. So long division method ni chapter polynomial last semester. So siapa yang dah lupa tu, you boleh refer balik note yang last semester. Okay. And for step 2, we need to determine the partial fraction for the proper rational expression. Okay. So example dia, makna step dia, you nak solve for case 5 ni, dia akan start bagi dengan you punya question tu in terms of improper. So from improper ni, you need to change into polynomial and proper. Okay, so from polynomial and proper, then you can change into partial fraction. Okay, so dia different compare to case 1 dengan case 1 until case 4. So yang before ni, case 1 until case 4, dia semua involve yang proper. So kita terus convert kepada partial. Tapi bila ada improper, makna first step dia you kena convert dulu into polynomial dengan proper. So bila you nak convert ni, kita akan pakai method dia long division method. So bila you dah convert into polynomial dengan proper, baru you boleh continue balik macam you solve for case 1 until case 4. Okay, makna kita add satu je step ke sini. You kena solve using long division dulu. Tukarkan dulu kepada proper. Okay. So example 30. So you boleh tengok example 30 ni dia nak you tukar in terms of partial fraction. Tapi dia in terms of improper. Okay. You have degree for the numerator 3, but the degree for the denominator is 2. Okay. So you kena solve dulu using long division. So you dah bentuk long division method. Lepas tu you kena ingat bentuk ni. So ni pun from chapter last semester polynomial. General form of the polynomial for the division of the polynomial. Okay. So you tukar in terms of general form dia. So you akan dapat macam ni. So yang ni yang tadi saya kata kita nak tukar in terms of polynomial plus dengan proper. Okay, so you dah tukar dah from improper, so yang asal is improper, so you tukar into polynomial dengan proper. So nanti yang you nak solve using partial fraction is this proper fraction. So you kena solve balik yang ini, change into partial fraction. So nak change into partial fraction, you kena determine balik lah, sama macam sebelum ni. You kena refer to the denominator, you kena determine the which cases tu. Okay, so ni saya solve. So kita dah factor dia case 1 lah, so both are linear. So case 1, so ni you punya general form of the partial fraction. Okay, lepas tu you need to solve for A and B. And using substitution method, and using substitute values of x, so you get b is equal to negative 3 over 2. And when x equal to 1 over 3, you have b the 3 over 2. So value ni semua comes from the factor. X negative 1 comes from x plus 1. X equal to 1 over 3 ni comes from 3x minus 1. Okay. So you get values A and B. Substitute balik, lepas tu you boleh integrate. Okay. So yang ni semua you boleh refer yang recorded video, example 30 ni. Okay, so untuk yang last example, okay, example 32. Okay, for example 32. Okay, for example 32. Okay, so you can refer your notes on example 32. Okay, so we need to integrate x cubed over with 2 minus x to the power of 2 respect to x. Okay. First, you kena check lah dia improper or proper. Okay, so kat sini denominator dia power 3 and for degree for the numerator is power 2. So kita consider as improper. So you need to change into proper dulu. Okay, so you change into proper by using long division method. Okay, so long division method we have x cubed plus 0x squared plus 0x plus 0. So you need to divide with, so ni you can expand lah denominator ni. So expand you have x squared minus 4x plus 4. Okay, x squared minus 4x plus 4. So saya nak solve using long division method, you need to multiply with x and then you have x cubed minus 4x squared plus 4x. Okay, so minus with, okay, so you solve, you have 4x squared plus 2 minus 4x plus with 0. Okay, so multiply with positive 4. So you have 4x squared minus 16x plus with 60. Okay, so you minus. Okay, so remainder is equal to 12x minus 16. Okay, so dapat dah you punya remainder. Next, you kena express in terms of general form of the division of the polynomial. So px over dx equal to qx plus rx over dx. Okay, so equal to, okay, so equal to qx is x plus 4. So plus with remainder is 12x minus 16 over with dx is x squared minus 4x plus 4. Okay, so kita dah tukar dah yang asal tu yang ini for improper. So saya dah tukar into form of polynomial dengan yang proper. Okay, so nanti kita nak solve balik yang ini. Solve balik yang proper ni by using partial fraction. Okay, so saya copy balik yang proper ni. So you have 12x minus 16 over dengan denominator dia we have 2 minus x to the power of 2. Okay, so kat sini you kena determine balik the case mana. So 2 minus x power 2 is linear and they repeat. Okay, so yang ni consider as case 2 So we have case 2. Okay, so kalau case 2 general form of the partial fraction is a over 2 minus x, so plus b over 2 minus x to the power of 2. So sorry ada gangguan sikit bunyi. Okay, dengar suara saya?
Dengar, madam.
Dengar
madam.
Pergi kelas. Kena habis. Okay, so ini you punya partial fraction. Okay, lepas tu kita nak step sama macam sebelum ni lah. Kita nak samakan denominator dia. So 2 minus x, you need to multiply with 2 minus x. Sebab kita nak bentuk macam ni. Okay, so yang atas pun multiply with 2 minus x. Okay, so this side tak perlulah sebab dia dah dapat yang sama macam bentuk macam ni. So dah sama, so tak perlu multiply. Okay, so nanti you akan dapat 12x minus 16 over with 2 minus x to the power of 2. Okay, so A you timeskan dengan 2 minus x, so plus dengan B over with 2 minus x to the power of 2. Okay, so you boleh cancel denominator and you need to solve for A and B. Okay, so 12x minus 16 equal to A 2 minus x plus B. Okay, so ini you boleh solve lah using comparing coefficient or you nak solve using substitute suitable values of x. For example, saya solve using substitute value. So saya let x is equal to 2. So x is equal to 2 ni comes from yang faktor ini. Okay. So when x is equal to 2, substitute all x with 2. So you have 2 minus 16. So equal to A. 2 minus 2 plus with B. Okay, so automatic this term become 0. Okay, so you can solve for B. So B is equal to A. Okay, so next saya nak assume lagi. Tapi faktor dah tak ada dah. So faktor you ada 2 minus X je tadi. So untuk yang last tu you boleh assume lah any number. Okay, sebab kita ada dua constant je A and B. So bila dapat satu, yang last constant you boleh assume any numbers. Contoh yang paling senang you assume X equal to 0. So when X equal to 0, substitute all X with 0. Okay, so nanti you boleh calculate value for A. So 2 minus 0 and plus B. B is 8, so plus with 8. Okay, so you dapat A. A is equal to negative 12. Okay, so you dapat dah B equal to 8 and A is equal to negative 12. Okay, next you boleh substitute balik A and B into this partial fraction. Ini okay, so saya copy balik you punya partial fraction. So we have to have x minus 16 over 2 minus x to the power of 2. Okay, so saya ambil daripada yang awal yang combine polynomial lah. Saya ambil daripada sini. You jangan lupa kita still ada yang polynomial term tadi. Yang partial tu saya baru solve yang belakang ni. So yang depan ni you kena copy balik. So tadi saya dah solve using long division. Result ada kita ada polynomial x plus 4 plus dengan yang proper. Proper tadi kita ada 12x minus 16 over with 2 minus x to the power of 2. Okay, so equal to x plus 4. So yang belakang ni saya dah solve tadi pakai partial. You ada 2 minus x plus with b over 2 minus x to the power of 2. Okay, lepas tu substitute values a and b. So a tadi kita ada negative 12. So minus with 12 over with 2 minus x and b tadi is equal to 8. So plus with 8 over with 2 minus x to the power of 2. Okay. So next kita nak integrate lah. Okay, so saya nak integrate this one. Okay, so integrate jangan lupa mesti sekali dengan polynomial tadi. So saya integrate x, we have x square over 2. And integrate 4 is 4x. Okay, lepas tu integrate yang fraction ni. So minus with 12, integrate 2 minus x, integrate 1 over 2 minus x is ln 2 minus x. So over dengan negative 1. So negative 1 ni comes from differentiation of 2 minus x. So dapat negative 1. Ni kena kalau you lupa, you kena refer balik masa kita topik integrations of the reciprocal function ataupun integrations of reciprocal function using substitution method. Ni saya pakai substitution sebenarnya. Ataupun you boleh pakai formula. Formula pun boleh kat sini. You kena refer balik yang part reciprocal function tu. Okay, lepas tu plus with yang belakang ni you kena solve using substitution. Okay, or you boleh solve using formula. Ni pun sama, you boleh refer balik yang previous notes. Kita ada 8, so saya nak integrate 2 minus x to the power of negative 2 dx. Okay, so saya simplify. Plus 4x, so kat sini dapat plus 12 ln 2 minus x and plus with 8. So kat sini saya integrate, saya pakai formula je, 2 minus x, so negative 2 plus 1, dapat negative 1, so over with negative 1, lepas tu you kena differentiate balik 2 minus x, dapat negative 1, plus with c. Okay, and final answer. Okay, so plus. Okay, so you have plus lagi 8 over 2 minus x. Okay, plus with c. Okay. So yang ni answers for example 32.
Madam,
Ya.
yang first kali X plus 4 tu kita tak perlu samakan denominator ni sebab dia bukan A dengan B kan?
Yang mana X plus 4 ni?
Yang dia sorang-sorang ni.
You tak perlu samakan denominator sebab yang ini kita consider daripada yang polinomial daripada long division tu.
Oh,
Kan?
okay.
So long division tu dia tak termasuk dalam partial. Dia macam sendiri-sendiri lah. Dia sendiri dia je. So dia tak involve dengan yang partial. Partial tu untuk yang fraction yang ni je.
Tapi bila kita nak integrate, kita baru masukkan dia sekali lah kan?
Betul. So
Okay.
bila integrate baru you ambil balik yang sendiri tadi. Kan? Ini. Baru you ambil balik dia. Baru you integrate. Biasa student dia terlupa. Bila dah siap solve habis sampai A dengan B ni, terus dia integrate yang ini je. Tu jangan lupa lah ambil balik yang sendiri tadi. Yang ni. You ambil balik yang ni tadi. Okay, dia tinggal pula dia. Okay, you jangan lupa. Biasa student biasa buat silap kat sini. Dia integrate yang ini je. Dia dah terlupa dah yang dia buat long division tadi. So you kena balik kalau improper, you kena ambil balik yang polynomial tu bila nak integrate. Bila integrate baru you kena ambil balik lah. You kena integrate dengan dia sekali. Baru you combine dengan yang partial tu. Okay? Boleh?
Boleh madam, thank you.
Okay. Ada lagi tak soalan? For improper. Improper ni dia senang je, tapi you kena ingat balik long division method. Long division you kena study balik topik polynomial. Sebab kita ada dua method, long division dan juga satu lagi method you ada synthetic division. You tengok kalau boleh pakai synthetic mungkin lagi senang pakai synthetic. Tapi synthetic tu kalau you ingat lagi dia ada certain condition, dia bukan semua boleh pakai synthetic division. You kena refer balik mana yang boleh pakai synthetic you boleh pakai, mana yang tak satisfy condition untuk synthetic tu then you kena pakai long division to solve. Okay. Okay, ada lagi soalan? Habislah. Okay, so kalau tak ada soalan, kita boleh stop dulu kat sini. Okay, nanti next class kita akan continue with chapter 4. Okay, so chapter 4 tu so far you boleh refer dulu yang notes yang saya ada bagi PDF version tu. PDF version tu separuh je. Nanti after you cuti mid semester break tu, masa tu saya rasa semua dapat buku dah. You boleh refer balik buku yang you beli tu. Okay, so nanti yang PDF version tu dah tak bagi lah. Okay, so tu je untuk hari ni. Thank you class.
Madam.